Alrighty, so welcome back. Today in this video, we're going to be continuing our statics review. We're going to be looking at equilibrium of rigid bodies. So in the previous section, we went through equivalent force systems, dealt with tension, dealt with playing around with formulas, and this equilibrium of rigid bodies is going to be somewhat similar. But I want to go ahead and dive into these, and let's go ahead and get started. So number one says a uniform beam of length 6 meters and weight 100 newtons is supported by 2 vertical ropes at each end. Calculate the tension in each rope. Okay, so what information do they give us? So we have the length of the beam. We know that it's uniform, which means it's balanced on both sides, symmetrical. We know the weight of the beam, and we know that there's 2 ropes, both of which are going to be interesting to us because we want to calculate the tension in each of those ropes. So what we're trying to find is the tension in each rope. All right. So what are some of the formulas that we need? Well, to start, let's get into the statics section. So I'm just going over to my bookmarks, hitting statics, brings me to section that I need to be in. And for this particular one, we are going to need the sum of the forces, right? Because we know that tension is a type of force. And so we have a few different things going on here, but so basically the sum of the forces in the X and Y is 0, equilibrium. So we're kind of looking at for a rigid body. So let's take a look at this. So it says a uniform beam. We got this beam, right? This little beam from here to here is 6 meters, right? And we know that it's got a rope here, and it's hanging up, right? Kind of looks like a sky lift. And we know that these are the 2 vertical ropes here and here. And we know that this beam force, know that this is 100 newtons. So what does our force diagram look like, right? Where are the forces going? So we got this 100 newtons coming down, and then we have tension, this rope coming up, and we got more tension, right? So we'll just say this is T1, T2. All right. So now I know that we know that from this is going to be our center, and we know since it is uniform, right? Means 3 meters from here to here, 3 meters, and then the distance from here to the center point is again 3 meters. Okay. to give our total to be 6 meters. Okay, so since this is symmetrical, we know that the sum of the forces in the y direction is equal to T1 plus T2 minus 100 newtons. But since this thing is symmetrical and is sitting in the middle, we know that T1 must equal to T2. And because of that, then I can substitute T1 in for T2. So the sum of the forces in the y is equal to T1, and now I'm substituting T1 in for T2. Let's say T1 is minus 100. All right, so now this just means that 2 T1 minus 100 is equal to sum of the forces. Now, T1 is equal to 50 newtons. All right, and since T1 equals T2, then we know that T1 is going to be 50 newtons, and then T2 is going to be 50 newtons. So our answer is going to be A. A little bit of substitution. Definitely need to know what uniform means, because that helped us out here. It didn't give us a lot of information, but they did give us enough to be able to draw some sort of conclusion. All right, so let's look at number 2. And so part of this is prior knowledge. Some of it is definitions, right? If you didn't know what uniform meant, you probably would be confused for number 1. And if you didn't know how to draw a picture, draw out what's actually happening, where the forces are going, it's going to be hard for you to walk yourself through logically of what's going on. So what helps me sometimes is to draw a picture. If you can't draw a picture, think through the problem logically and pay attention to key terms that are given in the questions, right? Okay, so number 2 says a cantilever beam of length 4 meters is loaded with a 500 Newton force at its free end. Determine the reactions at the fixed support. Okay, so we're given cantilever beam, right? Hopefully you know what a cantilever beam is, but if you don't, we'll look at it. We're given the beam's length. Okay. And we're given the point force at the end. All right, so it says determine the reactions at the fixed support. So we're trying to find reactions of fixed support. All right, so what does a cantilever beam look like? Let's see if we can search cantilever. Okay, that didn't go as planned. So I would like to show you what it typically looks like. But because I know this manual, I can navigate it the way that I would like to. So sometimes when it comes to visuals, the FE manual does have some charts that help you. So I'm searching deflection because I know that for deflection, beams typically come up. Okay, so cantilevered beam. Now why, when I searched it, did it not come up? So you're gonna need to know this manual by pretty much heart, because, or not by heart, but you're gonna need to know where to go for certain things, what to type in for certain things so that you can get there faster, right? Okay, so this is what a cantilevered beam looks like. You have a fixed point here and your beam, which this is dealing with a point load and it's bending the beam, right? But you have a fixed side and a free end side on the right side. Same thing coming here. Still for a cantilever beam, basically you have a fixed side, even though this one has uniform loading, the beam still has a free end and a fixed side. So that's what this we're gonna draw. Okay, let's draw this. So we know we got a fixed side here, and then we got our beam hanging off of it, right? That's a fire picture. That's my beam. Hopefully y'all like the picture too. All right, next. We know that the beam length is 4 meters. So all right, 4 meters. All right, we also know that we got a load at the free end of 500 newtons. So this is my free end of 500 newtons. Okay, determine the reactions. Okay, so for a fixed type of support, how many reactions do you have? Well, we go through them one by one, right? It's the only way you can do this is literally step by step by step. So in a fixed support, we have, we'll just call this point A, and this to be B, and we have a AX, we have an AY, and then we have a moment reaction MA. Hopefully this makes sense. Hopefully this is not completely new to you. Okay, so how will we go about solving this? Well, we can use, let's go back to static section. We can use the sum of the forces for equilibrium. Right? Sum of the forces in any given direction is equal to 0, and the sum of the moment is equal to 0. So let's take a look at this. So the sum of the forces in the x direction, I'm going to say, I'm going to erase some of this so that we can have enough room to write out these equations really quick. So the sum of the forces in the x direction is equal to ax, and there's no other forces acting, so ax is equal to 0. Okay, now sum of the forces in the y direction. All right, so we got negative 500 newtons coming down, and then plus AY. So AY to 500 newtons. All right, let's look at the moment about A, which from this, you don't want to waste any more time. If you get answers where I see AX is equal to 0, AY is equal to 500 newtons, none of the other answers have that. So I know that if I did this problem right, my answer should be B. Right. But let's just go through this. So let's look at the sum of the moment about A. All right. It equals the moment at A, the reaction moment. And then minus Y minus. Well, I'm saying everything. I'm saying if I'm taking a moment and if I'm taking a moment, let me point at things so that it makes sense. If I'm taking a moment about A, all right, and everything that's coming around is this way, right? If I have that force coming down, I know that it's going to whip around in the clockwise direction, and I'm saying that clockwise is negative, counterclockwise is positive. So this negative is negative because it's clockwise. So 500 newtons. But what's my distance? Because moment is force times distance. All right, so I got my force of 500. What's my distance? It is 4 meters. Okay. So MA is equal to 2,000 Newton meters. Cool. So it was in fact B. Alrighty. What is one difference for number 3? What is one difference between roller supports and fixed supports? Okay, so this is they give me that I have a roller. The information, I'm just comparing roller, and I also have fixed, and you want to find one difference. Formulas needed, not applicable. Let's actually see if they have a pen. If they show the number of reactions. I don't think the handbook ever shows you how many reactions a pen has. You just have to know that it has 2 reactions, right? Sorry, a roller. Looking for a roller, not for a pen, but either way, they don't have reactions typically, the amount of them. So just as kind of a refresh, pen, this is a pen, and it has we could say a Y, and then it has an AX. Just going through all the support. So another support is a roller. That roller only has an AY reaction. It doesn't have a this is a pin, it's a roller. And then you have like something that's fixed. All right, and so with fixed, you have a y, ax, and then you have a moment at a. Right. Okay, and that is a fixed support. All right, so that was just a little bit of a refresher. Okay, so for A, it says roller supports have two reactions. We just drew it out. We know a roller doesn't have two reactions, it only has one in the AY direction. So that's wrong already. Okay, roller supports have three reactions. Nope. Okay, roller supports have one reaction. Good. With fixed supports have two reactions. Well, we know our fixed supports has a AX, a AY, and a moment reaction. So that's three reactions. So we know that's not right. So our answer is D. One reaction for a roller, three reactions for a fixed support. So we get D here. So prior knowledge, this should become easy and natural to you the more practice that you do with supports. I mean, you're always drawing AX, AY moments about those points and trying to figure out what are your values there. So this concludes this section of statics review. This is for rigid bodies, equilibrium of rigid bodies. Next, we're going to be looking at some frames and trusses. This is what we're known for. These type of bridges and things. Some pretty cool stuff. So we'll get to that in the next video. Thanks for watching. Have any questions? Do not hesitate to reach out. And let's keep working.